Our table of contents. Okay, so at the top of your paper, we're going to label it number 37, 4.1, translations. And then put your name, date, period 2. Today's date is 10/26. Okay, so we're just going to kind of do a problem and then hopefully you guys will maybe recognize this. So for number 1, we are going to say, and yes, you have to copy the problem because this is one of the notes that I'm checking in your notebook check. If triangle, and math people are lazy, so instead of writing out the word triangle, we literally draw a triangle. ABC has vertices. Vertices mean literally the corners of the triangle. So these are the vertices. A, -3, 1. B, -7, 6. C, -2, 3. Determine. My pen is running out. Determine triangle A prime, B prime, and C prime. Prime means it looks like a little exponent of 1, but that's just how you label it. So the prime looks like an exponent of 1. So triangle A prime, B prime, and C prime. If it is translated, three right and down 5. Oh, I spelled and wrong. And so we're basically given an original triangle and we're going to have to make a graph of it. We have to determine the new coordinate points of the triangle. So this is where it would have been helpful if I would have found something online because it's annoying because we're going to have to make our own graph. That's why you should have grabbed a protractor because we're going to use it as like a ruler. Okay, so off to the side, I want you to, and like, I'm going to draw like a graph. You can, it doesn't have to be like the size of the whole paper. I'm going to go like 3/4 of the way. So I kind of went past the little hole in the middle. So here's my little hole. So it's like a good size graph. And then I'm going to draw. So it's basically like a big plus sign. It's better to go bigger than too small. And make sure you're using your straight edge so that way your lines are straight. And then I'm going to draw a little tick. I'm not actually going to number it, but I'm going to draw little ticks where the values would be at. So like, we're not actually scaling it, but we'll just pretend like it's numbered. So I'm put my little tick marks. That way it looks nice. So take a second, draw your graph. Okay, so now that we have our graph, what we're going to do is we're going to plot our original coordinate points. So it says triangle ABC has vertices, meaning corners, A -3, 1, B -7, 6, and C -2, 3. So to plot a point, remember you go side to side first, and then you go up or down. People get it confused because it's the opposite of rise and run. So when you started graphing lines in Algebra 1, people started plotting points wrong because they were thinking rise and run. So for A, -3, 1, you're going to the left -3, and you're going up 1 for your point. So starting at 0, 0, I'm going to go to -3, 1, 2, 3, and I'm going to go up 1, and I'm going to label this point A. So it's the original A. B is at -7, 6. So from the origin, once again, I'm going to go left 7, and I'm going to go up 6 because it's +6. So from 0, 0, left 7, 1, 2, 3, 4, 5, 6, 7. And then I'm going to go up 6, 1, 2, 3, 4, 5, 6. Goes to where B is at. My original B. C is -2, 3. So same thing. They actually all end up in the same quadrant. You're going left 2, up 3. 1, 2, 1, 2, 3. And then we're going to use our ruler to connect our points to make a triangle. So this is your original image. This is normally what would be given to you on your EOC. They'll give you a graph of something, and they could just ask for the coordinate points of the new image, or they could have you physically plot it on a, like on the computer. So I'm going to connect A to B and B to C and C to whatever. Do you guys remember doing this in school ever? Yeah, because X is first. So this is like your X axis. This is your Y axis. So you're going to -2 on the X. And then you're going up on the Y. So from here I went -3, 1. That's A. B is -7, 6. So from 0, I started again. I went -7, 6. And then C is -2, 3. From 0, -2, 3. So the first number is side to side. Second number is up or down. Okay, so that is your original image. What this is called is your pre-image. So I want you to add that to your picture. That is not going to be the answer. You have to take your pre-image and find an image. The image is the new picture after the translation. So this is just the problem itself. Now we're going to follow whatever it said. It said that it's translated 3 to the right and down 5. So I'm going to take every single coordinate point and I'm going to move it 3 to the right and then down 5. So I'm going to take A, I'll start with A, and disregard 0, 0. It does not matter. I'm using A, and I'm literally going 3 to the right, down 5, and I'm making something called A prime, which is basically where A is going to end up. So from A, I'm going 3 right, 1, 2, 3, and then down 5. 1, 2, 3, 4, 5. So A prime ends up right there. Can anybody tell me the coordinate points of A prime? I know it's a little funky because it's actually on the y-axis. What would that coordinate point be in reference to 0, 0? Would it be 0, -4, or would it be -4, 0? 0, -4. So off to the side, write A prime is at 0, -4. This is kind of like the answers because it's the answer to your coordinate points. And then we're going to do the same thing for B. The prime just means that it's the where it's shifted to, it's representing where the image is at. So B, I'm going to take B and I'm going to go to the like 3 to the right and down 5. So 1, 2, 3, and then down 5. 1, 2, 3, 4, So this is B prime. So disregarding A, disregarding the rest of it, what is the coordinate point for B prime from 0, 0? How much do I have to go to the left and how much do I have to go up? What would that coordinate point be for B prime? -4, comma, what? 1. So I went to the left 4, I went up 1, so B prime is at -4, 1. Then I have to find C prime. I'm going to do the same thing. I'm going to take my original C. I'm going to move it 3 right, down 5. What is C prime's coordinate points? 1, comma, -2. So from the origin, you're technically going right 1, down 2. So C prime is at 1, -2. And then once I have my 3 new points, I'm going to connect them with my ruler to make it nice and beautiful, nice and pretty. Your triangle should look like it stayed the exact same size. This is preserving the distance. It's preserving the angle measurements inside the triangle. The only thing that's changing is the location on the graph. So if it looks like your triangle ended up looking a little wonky and it does not look the same, it probably means one of the points are wrong. Because if A accidentally was over slightly, it would change the entire shape of the triangle. So it doesn't mean that the whole problem's wrong. It usually just means that one of the coordinate points is wrong, that you just miscounted. So in this case, your answers are your coordinate points of you shifting it and translating it. The pre-image is the original. The new one is called the image. So we'll put image next to this. So the image is technically where you have the primes. On your EOC, technically they could have a max of 3 transformations in one singular problem. So this is one type of transformation in one problem. We moved it one time. On your EOC, they could ask you to move it one time. They could ask you to move it 2 times, or they could ask you to move it 3 times. And you would just do it again, which is what we're going to do. We're only doing 3 problems today. And then we will practice it tomorrow. So let's go to number 2. So that's it. Number 2, we're going to do this without a graph. So if we didn't have a graph, we're going to figure out where the coordinate points are going to end up based on just using the words that are in the picture. So for number 2, sorry. Okay, so number 2, we're going to say that find the coordinate points. Or find the coordinates of x prime, y prime, and z prime. If x is at 5, -7, y is at 0, 3, and z. And the reason why I put a little line through my z is because sometimes they look like 2s. So if you're wondering. So z is at -5, -2. And it's being translated. Three left and up 2. So take a second, copy your problem. So instead of making a graph, which you could technically always do, make a graph and find your coordinate points, we're just going to find the coordinate points based on the information that's given. We know x is at 5, -7, y is at 0, 3, z is -5, -2, and it's being technically translated to the left 3 and up 2. So I want you to think we're going to the left 3. we're gonna draw a little arrow going to the left. We're technically going up 2. What we're gonna do is we're gonna write technically a rule to represent this transformation, which is usually on your EOC. So this is where it would not be multiple choice. And they would actually have little blanks for you to like fill in a number. So for your function rule or your function notation rule, they're going to describe this as changing the original X and Y variables to something else. It's kind of like an equation you can use to find its location. So it has a little arrow, and then you would have parenthesis, an X, leave like a little blank, and then we're going to put a comma, and then a Y, and then a blank, and then a closed parenthesis. So we have to basically fill in, and this is the way it looks on your EOC, is there would be like a little blocks, like a little block, like, you know, rectangle that you'd have to type in something, and a little rectangle you'd have to type in something. They would give you a problem, and then you'd have to type in what transformation is actually being done. So this is like an algebraic rule you could follow to this. So if you think about this visually, if you're going 3 to the left, do you think you should be adding 3 or subtracting 3 to a number if you're going to the left? Subtracting, because to the left, think about it on the graph, it's like your negative numbers. So we're going to say -3 because your X value is your side to side. So we're technically going left 3. That's why it's a minus. This is the left. If it said right, we would say add. And then it says up 2. So for my Y, because that's how much you rise and how much you, not how much you rise and run, but how much you rise. Since I'm going up, do you think I should say +2 or do you think I should say -2 if I'm going up? Plus. So this is kind of like your rule that we're going to calculate and figure out where it's going to end up without an actual graph. Because I'm going left 3, I'm actually minusing 3. I'm going up 2, I'm actually adding 2. So if the X was at 5, -7, I'm going to find X prime by using the rule I just wrote. So I have 5, I'm going to the left 3 units. So I'm doing 5 minus 3. So what's 5 minus 3 going to do? Be at 2. Because I went left 3. I was at -7. And now I have to shift up 2, so I'm going to add 2. So what's -7 plus 2? -5. If you actually had a graph, it would end up translating from 5 -7 to 2 -5 if I went 3 left and up 2. For Y prime, my original point was at 0, 3. If I start at 0 and I go left 3, what is 0 minus 3? -3. -3. So it was at 0, I went left 3, so now I'm at -3. My Y value was at 3, and now I'm going up 2. So if I add 2, where am I going to end up at? 5. So take a second, try to figure out these last coordinate points for Z prime. If I go left 3, up 2, and I started at -5, -2. So I'm kind of cheating. I'm not going to use a graph. I'm just going to think math-wise. How much would that be? So take a second, try to fill in your blanks. Try to fill in your numbers. Okay. That's what happens when you pick a seat by the door. I know you guys don't have assigned seats. You guys can still move around. What? Did something just ding dong dishes? Okay. Okay, so if I take -5 and I subtract 3, where do I end up? -8. And then if I have -2 and I add 2, where do I end up? 0. So this is technically where I would end up by using my function rule. So if they don't give you a graph, then usually I've seen them fill in like these little blanks where you have to like type in this kind of like the numbers specifically. The minus sign and the plus sign are usually there. You just have to type in the number itself, or they could ask for the coordinate points itself. So we're going to do one more problem. but this time we're going to translate it 2 times. Okay, so like I said, on the EOC, they could give you up to 3 transformations. So far, we've only done 1 transformation for each of these. So the next problem, we're going to do 2. And then by the end of the unit, we should do 3. So flip to the backside. Last problem. What? Okay, so last problem, number 3. So we're going to say triangle JKL has vertices J 2, 4, K -5, 2, L -3, 0. And it's translated one right, 2 down, then is translated again, 6 right, 3 down. Okay. So JKL, triangle JKL has vertices J 2, 4, K -5, 2, L -3, 0, and is translated 1 right, 2 down, then translated again 6 right, 3 down. Determine the coordinates of triangle J double prime K double prime L double prime. So double prime means that it's the second translation, whereas on the first one and the second one, we only had the singular. It looks like an exponent of 1. That means 1 translation. So since this is a 2 translation problem, we have double primes, meaning the second transformation. So we're going to draw a graph and we're going to scale it. And then we will shift it 2 separate times. So we're actually going to end up with 3 triangles on our graph. And normally on your EOC, they won't give you the same transformation in one problem, but we're only doing translations today. Tomorrow, on Monday, we'll do reflections, and then next week later on, we'll do like rotations. Rotations suck. I'm not looking forward to that. But for today, we're just doing these. So we'll have to use what we got to use. So make a pretty big graph. This is the last problem, so you can make it as big as you want. It doesn't have to be like the whole paper though, but so use your protractor, make straight lines, and then draw your little tick marks. And then once you have your graph, you can plot your original triangle. So J's original coordinate point is 2, 4. So you should be in quadrant 1. Remember, if you need to, you can always like write these out. This is like your positive, positive. This is your negative, positive. This is your double negatives, negative, negative. And this is your positive, negative. If you don't know how your coordinate points go. The first value is the X, and then the second value is your Y. So it's like side to side, and then up or down. So for J, 2, 4 should end up in quadrant 1. So over 2, up 4. 1, 2, 3, 4. And then I'm going to label it J. K is negative 5, 2. So you're going from the origin left 5 up 2. 1, 2, 3, 4, 5, up 2. So this is K. And some people think I'm moving really slow. Some people think I'm moving really fast. So if you're like good, you can continue without me. L is negative 3, 0. So that's actually a little Akko Taco. He's right on the x-axis. So negative 3, 1, 2, 3. I'm not going up anything. So it's on the x-axis. And this is going to be L. And then I'm going to connect my 3 points to make my cute little triangle. So this is your pre-image. It's before any transformations have been done. So when we're done with this whole problem, we'll end up with 3 triangles on our paper. And it should preserve the shape, the size, the distance of the triangle. Nothing should change. If your triangle looks funky in the end, that means like you did something wrong. The first transformation, the first transformation is 1 right and 2 down. So I'm going to transform it 1 time. Each coordinate point is going to go 1 right and down 2. That's going to represent transformation 1. So it'll be J prime, K prime, L prime. So 1 right, 2 down. So each coordinate point moved 1 right, 2 down. If you look at your second triangle that you have, it should look exactly the same size, exactly the same shape. It's preserving the distance, it's preserving the shape. Nothing's changing except its location. Now we're going to find the second transformation by shifting the orange one, the new one, again. People last period were going back to the original and then doing it. You're using your first translation, K prime, L prime, J prime. You're using this one to then move again. So I'm going to start at J prime. It says, then it is translated again, 6 right, 3 down. So I'm taking J prime and I'm going to go 6 right and 3 down. So J prime, 1, 2, 3, 4, 5, 6, down 3. 1, 2, 3. So J double prime is all the way over here. If I go to K prime, we do the same thing. K prime is now being shifted 6 right and 3 down. 1, 2, 3, 4, 5, 6. Down 3. 1, 2, 3. Last one I got to move is L prime. It's moving 6 right. Oh, 6 right, 3 down. 1, 2, 3, 4, 5, 6. 1, 2, 3. So the reason why it's double prime is because it was moved 2 times. So no matter how many times I move it, I should look like I have the same triangle in the end. Okay, so now we're gonna write out the quarter points. So for J double prime, after it's been translated 2 separate times, what would be the coordinate point of J double prime? How much do I have to go to the right and how much do I have to go down? 9, -1. So from 0, 0, if you go over 9 and you end up going down 1, that takes you to J double prime. So the quarter point's 9, -1. K double prime is right here from the origin from 0, 0. How much do you have to go to the right and how much do you have to go down? 2 and then negative what? 3. So 2, -3. And then from the origin for L double prime, 4, and then how much do I have to go down? -5. So technically those are your answers if you translate it 2 times. Because your original thing is being moved once and then twice, you end up having 3 pictures. You have the pre-image. Technically, you have a second pre-image after your first translation, then you have your third translation. So this is like your image. That's your final answer. How do we feel? Okay, not too bad. It's a little weird, a little crazy. Do you guys remember doing this? No? Does anybody remember doing this? You remember doing this? No, nobody else. It's crazy. Okay. Okay, so